Hello students, um, today we'll go ahead with the truss problems. Problem number 5. Okay, in the previous session I had completed a problem on number 3 and given new assignment problem number 4. Okay, let's see what's the problem number 5. Problem number 5, what you are supposed to determine is determine the nodal displacement, stress, strain and support reactions for the truss structure shown in the figure below. Okay, this is the structure given to you. Okay, this is having a width of 500 mm and height of 500 mm. Okay, the node force is applied vertical to downward direction 2.5 kilonewton and 2 kilonewton at this point, and I have put that node number as 3. Okay, node 1 is fixed, node 2 is having now roller support, node 3 is free, but forces are applied on it 2.5 kN in vertical downward and 2 kN in horizontal direction, and node 4 is fixed. The difference between the problem number 3 and problem number 5 is the roller supports are present, and this roller support, it is free to move in y direction, okay, and restricted to move in x direction. What does this mean? Its displacement u direction or x direction is 0. V it can displace. That is the hint for it. Okay. And coming to this node 3, node 3 is totally free. It can displace in x and y direction both. Node 1 is totally fixed, means x and u and v both are 0. And node 4 is also fixed, so u and v for this element is also 0. Okay. Discussing the problem here only. If we discretize this problem, okay, my node 1 is on the bottom side, node 2 here, node 3 on top right, and node 4. Okay, element number 1 is between 1 and 2. See here, element number 1 is between 1 and 2. Element number 2 is between 2 and 3. Okay, and element number 3, this element number 3 is connected between 3 and 1. Okay, my notations. Okay, and element number 4 is between 3 and 4 again. Okay, I have to tell these local nodes and all. For element 1, this is its length. Okay, it is 500 mm. You have to measure its angle at its local node 1. So local node 1 is this 1 only, and what is the angle made by it? It is 0 degrees. Okay, 0 degrees. Okay, just for you all students, you can pause the video here only and think about what can be the theta values for different elements, and later check out with the my discussion terms. Pause and just rectify your answers now. Okay, and now I think you have come back. See this, element 1 is now having a angle 0 degrees because its local node 1 is 1. Now element 2, its local node 1 is node number 2, that is this point. Okay, what is the angle made by this? From positive x axis you measure the angle in counterclockwise direction. This is 90 degrees. Okay, and this node 3. Okay, this is node 3. Okay, now element number 3 is here. Element number 3 is here, and as I discussed, element 3 is connected between 3 and 1. When element 3 is connected between 3 and 1, its local node 1 is 3. Okay, so when you are measuring an angle for this element 3, take positive x axis. From this, measure in counterclockwise direction. Okay, this angle comes out to be some reflex angle. Okay, this is theta 3. And coming to element number 4, element number 4 is on top side. Okay, it is connected between 3 and 4. Okay, so 3 is its local node 1. From here, if I try to measure its angle, it is 1 degree. Okay, So this is the major thing. Rest all thing you can, I think you can think of it. The length of first element is 500, length of second element is also 500, length of fourth element is also 500. Only length of third element has to be determined using this Pythagoras theorem again. Okay, square root of 500 square plus 500 square. Okay, done. Okay. Now this is the solution part. Step 1 is discretization. That is what I said you just now. This is my node 1, node 2, node 3 and 4, element 1, 2, 3 and 4. Its angle theta is given to theta 1 is 0, theta 2 is 90, theta 3 is reflex angle we have to determine, and theta 4. Okay. Now coming to step 2, it is element connected to table. Element number 1 is connected between 1 and 2. Okay. Element number 2 is between 2 and 3. Element number 3 is between 3 and 1. And element number 4 is 3 and 4. Okay. See here, I have always instructed to measure the angle of this element at this node. Okay. And you have to measure in counterclockwise. If you want to measure the angle of element 1, measure it at node 1. If you want to measure the angle of element made by element 3, measure it at node 3. At this point only, if you make the table in other way, that is, if you can and do its local node 1 as 1 and local node 2 as 3, then you have to measure the angle of element 3 at node 1. Okay. Now coming to the length of the elements, L1, L2, L4 is known to us. L3 you have to determine square root of 500 square plus 500 square. It is 707.106 mm. Okay. Later, angle made by the elements. Theta 1 is 0 degrees, that is known to us because it is horizontal. Theta 2 is 90 degrees, we have checked it. Theta 3, it is 180 plus, this is 180 up to here, plus this angle. This angle is how much? Tan inverse of opposite by adjacent. Okay, so that is why I have written here tan inverse of 500 by 500. Total comes out to be 225 degree, and theta 4 is 180 degree. Okay, then after that you write the element table. Element table, you are determining its length, angle, that is theta, cos theta, sin theta value, cos square theta, sin square theta value, and cos theta multiplied by sin theta. These are the values which you are going to determine for all the elements 1, 2, 3, 4. Okay, so that it will be easy for us to write the element stiffness matrix. Okay, you have already determined the lengths and you have already determined the theta. Go on determining the values of cos theta, sin theta, cos square theta, sin square theta, and cos theta into sin theta. Okay, and after that you can write the element stiffness matrix. Element stiffness matrix K1 is A1 E1 by L1 C square CS, C square CS. That is the formula for your truss. And S square CS, S square, C square CS, and X square. Okay, these are the formula. Okay, minus is for the top 4. Okay, for our work to make easy, what I have done is I have just written the upper triangular matrix in the first and second step only. But the last step, when I will be writing this K1 stiffness matrix, final stiffness matrix, I will write the full. I will not just write the half, I will write the full, so that when I am mapping those rows and column for the global stiffness matrix, it will be easy for me to collect the values. Okay. Now, similarly, you just need to substitute the values of A1, E1 and L1. Okay, all those cos theta, sin theta's values substituted, and this K1 is between the displacements U1 V1, that is node 1, U2 V2, that is its node 2, U1 V1, U2 V2, that's the displacements are being written on top of the columns and side of the rows. Similarly, you need to write a stiffness matrix for second element E2 E2 by L2. Okay, substitute this values of A2 E2 by L2 and your C square CS values. Okay, and now your element 2 is between node 2 and 3. So substitute all those things and simplify it, and it is displacements are U2 V2 U3 V3, U2 V2 U3 V3. All those things has to be written. Okay, similarly determine the element stiffness matrix for third element, A3 E3 by L3, C square CS C square CS, substitute those values. Okay, substitute those values here. Carefully substitute the positive signs and negative signs. Okay, and then this element 3, remember this table, element 3 is between 3 and 1, so its displacement will be u3 v3 first and then u1 v1. Don't just say write in chronological order u1 v1 and u3 v3. No, it totally depends on this your element connectivity table. I have intentionally made this type of connectivity table where the element 3 is first and the element number node number 3 is first and node number 1 is second one, so that you can understand if node connections are in the other way, what happens. Okay, similarly I have just written the element stiffness for third element. Carefully see this one, its displacements are u3 v3 u1 v1. Okay, on side of the row also I have written it u3 v3 u1 v1. Okay, now K4 element stiffness matrix for fourth element, A4 E4 by L4 and C square CS values. Substitute directly from the element table. You will end up with element stiffness matrix for fourth element. Now element 4 is between 3 and 4, so U3 V3 U4 V4. Okay, U3 V3 U4 V4. All these things has to be carefully written so that for us writing the global stiffness matrix will be easy. Okay, see the size of this global stiffness matrix. Global stiffness matrix, now it is having 4 nodes. Each node is having 2 degrees of freedom. So 4 2s are 8. 8 by 8 is the size of the global stiffness matrix. You can see U1 V1, U2 V2, U3 V3, U4 V4 are the columns. U1 V1, U2 V2, U3 V3, U4 V4 are the rows. 8 by 8 matrix. Okay, for you to solve manually, I'll tell you here only some hints. Okay, for you to solve manually, even the global stiffness matrix size can be 8 by 8 or 10 by 10, somewhat like that. Okay, at the end, even after applying boundary conditions, if the matrix size reduces to 3 by 3, then it is easy to solve us manually. Okay, for you to solve manually, after applying boundary conditions, when you eliminate the rows and columns, the size of the global stiffness matrix or the matrix, if it reduces to 3 or less than 3, then only you can solve the problem. Okay, else it is difficult for us to manually solve. Okay, you can have n number of nodes and that can be computed easily in computer. Okay, that part is other. Now after writing this global stiffness matrix, our next task is to write the global displacement vectors. The global displacement vector is u1 v1 u2 v2 u3 v3 u4 v4, and global force vector has to be written. For you to write global force vector, refer the question. Okay, and check it. My first node is not applied with any force, whereas second node is also free with no forces. But whereas third node is forces are applied, one is in x direction 2 kN, y direction 2.5 kN. Okay, and node 4 is free, means forces are not applied on it. But if we see carefully, forces are not applied at node 1, node 4 or node 2, but reactions are generated, reaction forces are generated, because it is totally fixed. Node 1 is totally fixed. R1x and R1y, both reactions are induced. At second node, it is fixed in x direction. X direction it cannot move, whereas y direction it can move. So reaction in x direction will be generated, that is R2x. Node 4 is totally fixed, so R4x and R4y, these are the reactions that are generated. Okay, see this. My F1x, R1x, F2y, F1y, R1y. Similarly, substitute all the values. Okay, after substituting the values, my step 5 is solving the equilibrium equation K into Q is equal to F. Just in the previous step, you have written this global stiffness matrix K, global displacement vector Q, and global force vector F. Okay, right, substitute all those values. Okay, and after substituting this, okay, write for boundary conditions. What are the boundary conditions? Because node 1 is fixed, u1 v1 is 0. Because node 4 is fixed, u2 u4 v4 is 0. But node 2 is having roller support. Free to move in y direction, but x direction it cannot move. That is u2 is 0. Okay, corresponding columns has to be deleted. Okay, so u1 v1 u2 u4 v4, those columns has to be deleted. Corresponding columns has to be deleted off. We'll end up with reduced size of matrix. That is in my step 7. Step 7, solve for unknown displacement. Okay, after applying this boundary condition, take the reduced size matrix. Okay, 10⁵ is common outside, you have to write it, and the remaining components which are not cancelled, okay, into the displacements u v2 u3 v3, okay, and the forces. Solve the above set of matrix, you get the solution. Okay, that is v2 is minus 0.165, u3 is minus 0.064, v3 is minus 0.1655. okay, this is the values. Okay, how to solve this matrix? This can be converted into upper triangular matrix by doing some row operations, that is writing the augmented form and then doing it in upper triangular matrix, and then do back substitution and get u3 v3 first, then u3, then v2. That can be done. If you want some other method, or you can also think about even after doing the certain row operations, some manipulation or mathematical errors, manual errors that can be introduced by yourself. Okay, to check whether your answers are correct or not, what you can do, you can write it in directly solve it in calculators. Okay, I hope some students know it, how to solve it by calculator. If not, see it how to solve it. This write it, take it as 3 equations, 3 unknowns. Okay, go to equation mode, 3 unknowns. Okay, select it, and then it will ask for a1 value. a1 value is 0.7 into 10⁵ is common outside, you have to go on multiplying for each term. Okay, either you do like this, or even a1 you just write 0.7, b1 is 0, c1 is minus 0.7, d1 it will ask, d1 is 0 here in this case. Similarly, substitute a2, b2, c2, and this is d2. While writing d2, divide it by 10⁵. That's it. Okay, instead of writing for 9 columns, you can 9 terms, you just divide it for 3 terms. That's it. Okay, solve this using calculator or by doing the elimination method. Okay, you will get u2, v2, u3, and v3 values. After calculating this, my step 8 is determining the strain. Strain is b into q. B is 1 by L minus C minus S, u1 v1, u2 v2. Strain in first element is 0. You calculate stress. Stress is equal to E into strain. 0 is the strain, so 0 MPa is the stress induced. Okay. Second element, you go determine the strain and stress. Strain is again B into Q, 1 by L minus C minus S, CS. u2 v2, u3 v3 are the components of displacements. Okay, calculate strain is 0 here. Stress is also 0. Stress is equal to E into strain. Calculate the strain in the third element. Third element strain has 1 by L minus C minus S, CS, u3 v3, and then u1 v1. Remember this displacement associated with it, very carefully you have to write it. These are the points where you actually jump out and you write it mistakenly. Okay, then strain you calculated it. The calculated value of strain here is 1.009 into 10⁻⁴. Stress is E into strain. If I multiply it, it is minus 7.068 MPa. Okay, fourth element strain you calculate 1 by L minus C minus S. The displacement associated are u3 v3 u4 v4. Okay, now calculate the strain. strain comes out to be 1.28 in 10 raised to minus 4. Okay, and calculate the stress. Stress is E into strain. 8.96 MPa is the strain stress induced. Okay, now after determining this stress, strain and stress, you need to calculate what is the reactions. To calculate the reactions, you have to use this step 5 matrix. In the step 5, you have this reaction R1x. To know R1x, what you can do, you have to multiply this row to this column. Okay, similarly, if you want R1y, multiply the second row to this one. Similarly, to get R2x, multiply the third row to this value column, and multiply the seventh row for getting R4x, and multiply the 8th row to get R4y. Okay, remember 10 raised to 5 is still outside, and you have to do it, take it inside for each row. Okay, I'll show you the solution of these reactions, multiplying those 10 raised to 5 outside. Okay, whichever term is 0, directly you can go on writing 0, or else write it the first row and then calculate in the second row. Okay, R1x comes out to be 2.49 kilonewton. See the R1x value, 2.49 kilonewton. R1y is 2.4948 kilonewton. Okay, multiply the second row, taking the R2x, that comes out to be 0 Newton. R4x minus 4.48 kilonewton, and R4y is 0. Now, as I previously told you, to check whether our answers are correct or not, if you remember, 2 kilonewton force was in positive x direction. 2 kilonewton force is in positive x direction. Check out this R1x and R4x. R1x is 2.49 kilonewton. R4x is minus 4.48. Minus 4.48 plus 2.49 comes out to be minus 2 approximately. Minus 2 kilonewton. What is that? Is our 2 kilonewton force applied in positive x direction. So reactions and resultant reactions is minus 2 kilonewton reactions. Okay, that is okay, correct. Coming to our reaction in y direction, R1y is 2.49 kilonewton, whereas there is no other reactions, here are 0, and our force applied in y direction is in node 3, 2.5 kilonewton in vertical downward direction. So I have received reaction of 2.49 kilonewton in upward direction. So what I can say is my results are correct at the end of the solution. Okay, that is how we can predict our answers are correct or not. Okay, this completes your step problem number 5. Coming to the last problem with respect to trusses. Okay, this is for your solution at home. Okay, I have given you the structure. Okay, you have to determine the nodal displacement, strain and stress and support reactions for this figure. Node 1 is bottom side, see here. Node 2 is upward, node 3 is here, node 4 is different here. Okay, downward direction force is 20 kilonewton and 10 kilonewton. Okay, just for your reference, we have already given you L1, L2, L3 as 300 mm, A1, A2, A3, that is area is also 300 mm square. Young's modulus E1, A2, A3, that is all the things are made of same material, that is 2 into 10 raised to 5 MPa. Okay, I will give you the hints. Okay, element 1 should be connected between 1 and 2. Element 2 is between 1 and 3. Element 3 is between 1 and 4. You can see all the stiffness matrix will be having this nodal displacements 1, U1, V1, U2, U1, V1. Okay, those values has to be multiplied, added from all the 3 stiffness matrix. Rest all terms you can think of. Okay, and just to check what will be the angle made by element 1, if you are connecting between 1 and 2, then the angle made by it will be 90 degrees. Okay, and if at all you think of some other values, see here I will take this element 1 is connected between 2 and 1. So why only I should follow sir? I'll follow something else. If you want to follow element 1 is connected between 2 and then 1, that is local node 1 will be 2 and local node 2 will be 1. In that case your angle theta will be 270 degrees, my dear friend. That's it. That's the only change. Okay. Now coming to element 2. Element 2 is connected between 1 and 3. So the angle made is 45 degrees. 45 degrees directly given to you. Okay. And element 3 is between 1 and 4. So if it is between 1 and 4, the angle will be 0 degrees. If you want to take between 4 and 1, then the angle will be 180 degrees. Okay. Those things has to be taken care and try to solve, and if you are any difficulties, let me know. Okay. Thank you.